So there are certain services that we use for storage as well. And I believe I forgot to tell you guys one thing. Uh, when we are talking about Azure VMs and scale sets and app services, we can host any applications, right? But when there is a specific request of the customer that customer wants to host an application, or let's leave the application. The customer wants to host a website of their own, right? It's a dynamic website and they want to run that website. Do we have any services for that? Yes, we do. The websites can directly be hosted on app services as well. You can directly host any kind of websites. We will do the integration of the database into that website and stuff like that. Everything will be done and it will be hosted quite comfortably on Azure App Services. So you can just keep that as a pointer in your head whenever you hear the keyword that, okay, I'm looking to create a website. You ask them a question, is it a static or a dynamic website? Whatever they say, the answer to both the questions is go with Azure App Services. It's cheaper and it's great performance, and the performance is very customizable, right? And it's an enterprise grade security, enterprise grade performance that we provide in app services. So that's just one thing that I believe that you should remember. Anyway, we were just about to talk about Azure storage services, right? So whenever we talk about any of the cloud storage services, what that means is that uh, customer does not really have to buy any kind of physical storage. They don't really have to buy any kind of hard disks. They don't have to buy any kind of NAS devices. They don't have to buy any kind of file servers, right? But before we get into that, let me tell you what those devices actually are, right? So hold on. So has everybody heard of this thing called, well, everybody would have. It's called an HDD, hard disk drive. Hard disk drive is just a simple disk that can help you store GBs, and in fact, it can now help you host terabytes of data, well, in a single place, right? That's what a hard disk does. So you can connect it directly to a server, connect it directly to a computer. That's what you do on-prem, right? So you can use an HDD. You can, other than that, you can use a flash drive or a pen drive, as some people call it. They can use CDs, DVDs, tape drives as well, right? But all of these storages that are just named, these storages are usually for personal use. What do I mean by personal use? That they are more geared towards one person using them at a particular time. They are not for simultaneous access. Although you can do simultaneous access on some of them, but uh, it's not the primary thing that they are designed to do, right? It's not the first thing that you would want to do on that, right? So all of these are for personal storage, and they're pretty good for personal storage, but we can replace that with a cloud storage as well, right? Other than that, we have storages that are called as network storage. So what is a network storage? It's very simple. When multiple people in an organization, right, or in an office, in an organization, in a single, uh, on a single floor, when all of these people are accessing a common storage, everyone is accessing a common storage. That is called a network based storage. Everyone is connected to that storage, maybe using their Ethernet, or maybe using their Wi-Fi, or maybe using some kind of a domain configuration setting or something like that. But this storage is common to everyone, right? There's you guys must have seen that to some extent, that there is a folder that is clipped to everyone's computer. Sometimes it's a network drive that is clipped to everyone's computer, that you can keep files there, copy and paste files there, and it can act like a centralized repository of files, right? That's basically a network storage. Okay, so there are several types of network storages. There is something called as a file server. There's something called as a NAS, and there's something, oh, it's a SAN. There are These are the common types of network storages that we have. All of this, by the way, so far, all of this is on-prem storage. So you have these options for on-prem storage. For personal access, you have HDD, flash drives, and stuff like that. For network access, for common access, you have these three: file server, NAS, and SAN. Can anybody tell me what a file server is? And by the way, some of you may also have heard of this thing called as. Okay. Anybody wants to try what's a file server? No one? All right.
It's a server which stores the file. It's a file server.
Stores the file in a nutshell, where everyone is storing the file and you are accessing the files commonly. That's a file server, right?
Yeah.
Multiple people have these, like I was giving an example earlier, people have these network drives attached to their systems. That's basically that's basically an indicator that okay, your organization is using a file server, and all the people who have that network drive attached to their computer, mapped to their computer, we use the term mapped here, is using a file server, right? File server again is a common server, common repository of files. Anybody? FTP. What's FTP? Have you guys heard of it?
File transfer protocol.
It's a file transfer protocol. Some people use FTP storage as well. Well, there is a difference. So FTP is again a centralized storage where it's a centralized repository where the files are kept, and some people can access the files. There's a username and a password involved here as well, right? You can do that with the file server. So all the things are said for file server hold true for FTP storage as well. But there's a difference between FTP storage and a file server. There's a difference. In file servers, you can edit the files without downloading them. You don't have to download the files and then edit them, right? In case of FTP, what happens is that, okay, you see an Excel file on the FTP. First, you have to download the Excel file, then you can edit it. You can't edit the file from the FTP. FTP storage only lets you upload the files, download the files. It does not let you make changes to the files. Both of them, I should say all of them, they are still network storages. They're still common storages used by everyone in the office or most people in the office. They're centralized. Okay, file servers, FTP. What is NAS? NAS stands for network access storage, right? In most of the cases, in most of the organizations, NAS and file server are exactly the same thing. NAS is just the physical box. File server is what we call it. Okay. SAN again is a backend storage. It's really fast, but again, it's a centralized storage that can be used as a file server in many cases as well. But we don't really need to get into so much detail. So we have two things that we have to worry about: file server and FTP. File server is a centralized storage that can be on which you can upload and download files, but also you can make changes to the file on the storage, right? You don't have to download it. In FTP, you have to download it or you have to upload it, right? That's a difference, right? Then we have these cloud alternatives to all of these solutions. We can use these cloud alternatives to these solutions. If a customer is using FTP or if the customer that we are talking to is using a file server, right? We suggest them to use Azure File Share or Azure Share, right? You can use either of the terms. Azure File Share is the product that we are going to patch. If the customer says that, hey, I am using a file server, that file server is what 2 terabytes large and there are up to 2 terabytes of files. And do you have any solution for that? And of course, we do have a replacement for that. We have Azure File Share. Now, why would somebody go for this cloud storage? First of all, with the file servers, they are expensive, right? File servers are expensive, right? And file servers are awfully difficult to manage. If anybody here in this meeting has managed a file server before, you would know that the file server is such a hard thing to manage because everyone in the office is accessing the file server and people tend to make a lot of mess. There's you have a file server. After a few days you would see the files would be in you would be there in a disordered manner. There would be a lot of copies of the files. Maybe multiple users uploaded the same file, so there's a single file that's there multiple times. So basically it's an untidy form of storage after a while, and also you're using up a lot more space than you would have because there are copies of the files on the file server now. Because maybe I'm storing a couple of files, and let's say Ashish here decides to upload a couple of files too, and the files happen to be the same, right? So now both our copies lie there on the storage, and this can happen with multiple files. There was a research done by Microsoft, as a matter of fact, a few years ago, is that on almost all file servers, almost all file servers, the duplicate data is 80%. 80% of the storages, or 80% of these common storages, it's just copy of the data, copy of a copy of a copy of a copy. So basically, essentially, if I was using 100 GBs of data or 100 GBs of storage, I was essentially using 20 GBs of storage. I essentially needed 20 GBs of storage, but I'm using 100 because there are so many copies. I'm just wasting that amount of storage, right? So first of all, it's expensive. It's difficult to manage. Management is difficult. Then there's a cost that there's a lot of wastage here. There's a lot of wastage in this case. Uh, then you have other things as well. So expensive, unmanageable. There's a lot of wastage, and it's uh, you can say that, let's say you want to increase your file server's capacity. You want 100 GB more storage. Now what you have to do, you have to go out in the market, purchase some hardware and extend your file server. And when you don't need that storage, what you're going to do? Well, you're stuck with it. You can't just go out in the market and sell a part of your shared storage. It does not happen like that. So basically, you have to put into the hardware considerations as well. So these are all the disadvantages of using an on-prem file server. Okay, then comes in Microsoft. What we are saying here, that if you want to use a file server, Mr. Customer, what we offer you is an Azure file share. This is a file server. This is a file server that's been created by Microsoft, that's been hosted by Microsoft, and that's being managed by Microsoft. Everything is taken care of by Microsoft. All the customer has to do is sign up for it, and we are going to give them an IP address, and they would be able to access this server from wherever they are. One of the one more problem with the file server is that it's localized. If you go out of your office, well, you can't access file server anymore in most of the cases, right? Excuse me. So in most of the cases, if you are using these file servers, they would be localized. So what Microsoft does is we are hosting these servers in the cloud, and they are accessible from anywhere across the globe, right? We are going to manage them. We are going to make sure that if there are copies of a copy of a copy, you don't pay for copies. You just pay for the original data. So what do we do in order to do that? We call this technology as deduplication, or dedupe, data deduplication. It's a process of removing copies, or it's a process of removing the duplicate data so that you are using the amount of storage that you actually need, right? Not the date, not the storage that is being occupied by copies, right? Now, and this is actually pretty cheap. It's not expensive at all. If I remember correctly, it's around uh, $1.20, I think. $1.20 per GB per day, something like this. $1.20 per GB per day for the storage. This is actually pretty awesome for a common, or for a centralized storage, right? So this is one thing that is there as well, right? Also with Azure file share, what we have is that you can have this anywhere access. Hold on. You can have this anywhere access on our storages. So it's a decentralized storage. There's no wastage. It's not expensive. It's managed by Microsoft, right? And your customers, by the way, and your users, or the customers' users, they are not going to realize that there's a difference between this storage and the on-prem file storage. It's going to feel exactly the same to the end users, right? So the end users can save as much data as they want to, or they are not going to realize that there's a difference as to where the data is being stored. So basically, it can be mapped to the user's systems too. So it can be mapped to PCs as well. So you can map it to any PC. And to the user, it would seem like, okay, this is a local drive. Let's keep the data here, or let's download the data from here, right? The only requirement for this is that you have an internet connection. If you don't have an internet connection, there's no way to actually access this. Well, makes sense, right? Because it's already on the cloud. It's exclusively on the cloud. Okay. Also, in this case, you are paying for the storage that you are using, right? If you're using 200 GBs, you're just paying for 200 GBs. You're not paying for 256, for example. So the exact amount of storage that you're using, you're going to pay for that. Also, if you have a well, if you want to increase the storage or if you want to decrease the storage, well, you can do that in an instant. Like we discussed yesterday, the storages on cloud are elastic. The storage is also elastic. It's called Azure File Share. It can be mapped to PCs. It is elastic storage, and it's totally managed by Microsoft Azure, right? This is the Azure File Share part of the things. So what does it do? It replaces your file server. It's a file server replacement. And it's replacement for a file server, and I should say for FTP as well. It's just a better solution, right? Okay. This is optimized for sharing, right? Because it's a common centralized storage and multiple people are sharing the data with each other and stuff like that. So this is a storage that's optimized for sharing, right? And let's say you're talking to a customer now and you tell them that, okay, we have something called as Azure File Share. It can map and stuff like that, blah, blah, blah. Then the user says that, dude, I require a storage that is going to store terabytes and terabytes of data that I'm not going to use every day, that I'm not supposed to share, that I'm not sharing with my users, but I just want to keep it. I just want a repository where I dump all my data, right? If I require it, I'll probably get from there. If I don't require it, I'll probably dump it, right? We have a solution for that as well. In that case, you are not going to use Azure File Share because this is the file sharing solution. But there is a solution that is optimized for storing the stuff as well. It's called as blob storage. Some people call it container storage, some people call it blob storage. It's exactly the same thing. Blob storage is a super inexpensive storage. You are not paying a lot of money in order to use a blob storage. It's actually approximately 6 times cheaper than your Azure file share. Blob is 6 times cheaper, approximately. 6 cheaper than your than your Azure file share. So there are some features in this as well, right? You can practically store infinite amount of data, right? There's no limit to how much information or how much data you can store. You want to store 2 GBs, be my guest. You want to store 2 megabytes, be my guest. But if you want to store 2 petabytes of data, terabytes, petabytes, zettabytes of data, basically be our guest. We are going to help you host that data on Azure Blob Storage. So it's practically infinite, right? Well, nothing can be practically infinite, but again, it's such a big storage that you will run out of data, we won't run out of space, right? So it's unbelievably elastic, right? Other than that, it can be used for any. It has 3 tiers actually. It has 3 speed tiers. Actually, it has hot and cold. If there is data that you access every day, right? You want to access some data that you store on the blob every day. So you want it to be fast. You want the access of the data to be pretty fast. Then then the storage is automatically going to be in hot storage, or what we call it as hot tier, right? You can have the storage in hot tier, right? But if you don't use your data for months and months and months, then you don't want your storage to be very fast. You just want your storage to be inexpensive, right? In that case, the data moves to cold tier, right? What does cold tier do? Your storage expenses become way cheaper, but so the speed also comes down. But in hot tier, it's slightly more expensive, but the speeds are really good too, right? So if you have a lot of data to store, right, you will store it in the cold tier. If you have some of the data to store, still a lot, but I'm still going to use it every now and then. I'm going to probably go with the hot tier in this case, right? So that's the difference between cold tier and hot tier, right? And by the way, if you want to archive your data, if you want to just put in your data, upload your data and forget about it, well, then you would need like a super inexpensive storage, because I just want to take my data and dump it somewhere, right? We have a solution for that as well. We call this as archive. We call this as archive tier. What is archive tier? Is okay. In hot tier, you are going to access the data every now and then. In cold tier, you're not going to access for a very long time. In archive, speeds may be as low as possible, but what I'm concerned with is, because my data set is super huge, I want the storage to be super inexpensive too, right? Because I have a lot of data and I'm probably not going to access it. So rather just give me a slow but super inexpensive storage. So in that case, the data is going to go into the archive tier, right? Some people who have used AWS or heard of AWS may have heard of glacial storage. Glacial storage is a combination of this hot tier and archive tier. Anyway, we don't have to get into that. So if you want to compare the performances of the three things, well, this has performances just like an SSD, a solid state drive, a really fast hard drive, right? Cold tier has performance just like a regular HDD or a magnetic disk. Archive tier actually has the performance of tape drive. It's really terrible, right? Read write speeds are very low, but the cost of actually hosting a lot of data comes really down, because you're using the tapes instead of the hard drives. Okay. Are there any confusions or are there any doubts so far regarding all of this?
Just a quick one. So if you had data stored in blob, using blob storage, and you had a huge amount of data, so you wanted to store loads of it in the archive tier so that it was as cost efficient as possible, I presume you can move it across to other elements of Azure to make sure the data is accessible faster.
Okay, that's a good question. First of all, as a user, you are only able to access these two tiers, cold tier and hot tier, right? And you can access both of these through Azure applications, right? If your data stays in the hot tier for 30 days and you're not using it, it will automatically be moved to cold. Okay. If you access any data that's in cold, it will automatically be moved to hot. But now here's the catch. If the data stays in cold tier for 6 months, that's 180 days. If it stays there for 180 days, then Azure will automatically move it to archive tier, right? So it's a win-win situation for everyone. Because you did not use it for 180 days, the likelihood of you requiring it after that is really low. Well, in all fairness, it would be, right? So your data that's in cold tier will automatically be moved to archive tier, so it will bring down the cost or the monthly cost of the storages that you're using. By the way, if you want to use that data on other Azure services, you can always link those services with the blob storage and with the data that's in hot tier or cold tier. Anyway, you can still access this data from anywhere in Microsoft Azure. Not just in Microsoft Azure, actually, you can connect your blob storage to your on-prem devices as well, right? Has everyone seen OneDrive? I'm pretty sure that everybody must know about OneDrive by now, MWP, right? So
Yeah.
OneDrive is actually built upon blob storage. This is the blob storage is the backend of OneDrive. In the backend where the data is stored, it's stored on blob storage in Microsoft Azure. For front end, for the users who are just accessing, for them it's OneDrive, right? So we have been using blob storage for longer than we actually think we have been, right? So that's what Microsoft does. But in this case, since you are going for this whole infrastructure kind of a thing, right? You are going for your own storage. I'm going to manage my own storage. I want to be the boss of my own storage. I would not suggest any customer going to go for OneDrive, because again, OneDrive comes with an Office 365 subscription. Well, Blob can be standalone. Just get an Azure subscription, zero cost. Create a blob storage, just pay a monthly fees or just pay a monthly price for the blob storage. That's about it, right? So that's one thing that customers can look into. So if your customer is looking for a replacement for a file server, now this is as simple as possible. I don't want anybody here to be doing this requirement gathering. Hey, Mr. Customer, are you using ABC or not? Then I have this. But let's make an exception here for Azure file share or for cloud storages, right? We need some sort of requirements as well, right? First of all, one of the questions that would be pretty good in this case would be, are you guys using any kind of file server? Or if you can get to that point in a more subtle way or in some other manner, in a matter of speaking, right? You can get to the conversation, are you using a file server? And if the answer is yes, now that becomes really important. You can use all these points that you would understand that's really expensive. It's hard to manage. There's no data deduplication. You'd require hardware every time and it's localized. You will tell them the disadvantages of what they're using, right? Then comes in Azure file share because it's a replacement for a file server, right? But if they are looking for something that's more or less like a file dump, or if they're looking for something that's more or less like a storage backup, in that case as well, we can pitch them a blob storage, right? So I would say that when you are pitching file share, you will again look for file server or FTP. But when you're pitching for blob, you will look for people looking for bulk storage, right? Because if they are not looking for bulk storage, if they still go to blob storage, right, it's so inexpensive, it's so cheap that obviously it's going to be almost zero revenue, right? So it's six times cheaper than six times cheaper than your Azure file share. So it comes down to be what, 20 cents a day per GB, something like that, and that's super cheap, right? So of course it's one of the major factors, right? It's probably the cheapest storage on the market. Well, actually, the second cheapest. The cheapest is Google, but it's not very good. It's not very reliable. Okay. Any questions so far out of all this?
I can't read the last writing on blob. If you could bring it up, please. Thank you.
Okay. Can you read it now?
No, because I have this bar in the front, and I can't seem to remove it, so I can't really read the notes.
Okay. Let me remove everything else for you. Hold on.
Oh, thank you. Thank you. Thanks.
Okay. So when you're talking about blob storage, make sure that you're talking somewhere around the lines of, hey man, you need a bulk storage and you need it to be very inexpensive, but the performance benefits are still there. You can see it right here. Hot tier is SSD performance. So you're not just skimping on the performance and just going for the cheaper thing. No, it's just a bulk thing. We use it as a backend for products, right? For Office 365 and stuff like that, we use blob storage as a backend. Whatever data you're storing with Microsoft Cloud, if you're using Outlook, your data is stored in the SharePoint. Technically, if you're using Outlook, your data is stored in the SharePoint that is connected to OneDrive. All of that, backend is still blob. Everything that you're using on Microsoft storage is essentially blob storage, right? In a sense. So Microsoft so basically, if you want to use this point as something of a, well, as somewhat of a feature, you can of course use it, right? Because Microsoft use blob storages for everything, right? Everything is built upon blob storages in Microsoft environment or Microsoft architecture. Okay. Any more questions?
Yes, Melissa here. I have one question.
Yes.
Going back to the hot tier and the cold tier, if I'm a customer that has all my storage, if you like, classed under the cold tier, and as you said, the speeds are slower, the moment I access it, did you say it reverts to hot tier?
Yes, not all of the data, only the data that you're accessing. Let's assume that you inserted 10 GBs of data in cold tier, which was smart because you figured that, okay, I'm not going to be using it for a while, so why not keep it in hot tier? But then you realize that, okay, I need a file there that's 100 MBs, right? 100 MBs, or let's say 1 GB for the sake of simplicity. So that 1 GB would be moved to hot tier. Other 9 GB is going to stay in cold. It's not that the whole thing is going to become hot tier again. So
that
only
makes
the data.
sense.
Yes. Any more questions?
Once it goes to archive tier, how easy it is or how fast it is to, if the client decides to, he needs to access it again?
This is painfully slow. As you would know, tape storages are known for, first of all, known for two things. They are very durable. They stand the test of time, right? And the second thing that they are known for is that they are super inexpensive. They're dirt cheap. They are super inexpensive. But this comes at a cost, right? What is that? Is that they are super, super slow. Technically, if your data moves to archive tier as a user, right, it will essentially, you have a waiting period of 6 hours. If you want to access that data again, you have to request it, come back after 6 hours, then take your data, because from archive it will be moved to hot tier for you. So if you have if well, actually what they do in Microsoft data centers is that they move that to tape storages, right? And tape storages cannot be accessed directly by the computers, the modern computers. Tape storages are just too slow. So what do we have to do with tape storages is that we have to copy the data from the tape to a faster storage, and then we have to give them the access. So there is this waiting period of 6 hours for anybody to be able to access their archives. This is called a rehydration period, rehydration of the blob. This is essentially a dried up storage. So we are rehydrating that up for you so that 6 hours later you can access that. So
Thank you.
archive storage.
That's not too bad. Thank you very much.
So archive storage is actually, now this one is actually the cheapest storage in the world. Blob storage overall is the second cheapest, but archive part of the blob storage is the cheapest in the world, right? But one thing is that archive storage is there with Google Cloud as well. If a customer is using Google Cloud services, they also have the archive storage if they want to go with the archive storage. But their waiting period is less than a minute. Our waiting period is 6 hours. Google Cloud Platform waiting period is less than a minute because they never move it to the tape. They keep it on the HDD, right? Is this an advantage? Would we say it in a sales call? Probably not. This is for your information. But this is what makes this archive storage the cheapest in the market because, of course, it's stored on tape. It's going to be slow, but if you're looking for something that's more cost effective, I wouldn't mind waiting for 6 hours, to be honest, right? So that's one thing to put into perspective. So this could come as a customer's question or customers. You could say that anybody would say that Amazon and Google don't have any kind of waiting time. Why do you have 6 hours? This is the reason, so that your storage is cheaper. Okay. Any more questions?
Yeah, so sorry, just a bit of clarity on what I asked earlier because I'm not sure I fully understood. So it understood. So if we move some data, so the data goes through the tiers of blob storage over time, hot tier to cold tier, and then after 6 months to archive tier. If it takes 6 hours or whatever to go from cold tier to archive tier, does it then take 6 hours to recover that same data? It's just it's just a data accessibility piece really. I just want to understand if data is put into archive tier and these tape drives, how easy is it to recover from the archive tier and then access it at a decent speed?
Okay, that makes sense. Okay, that's a fair question. Let me explain it to you. Hold on. Okay, let's say there are three storages, cold, and you have this cold tier, archive tier, and hot tier. Let's say originally your data was in a hot tier, right? If it stays here for about 30 days, right? If it's here for about 30 days, then what's going to happen is that it will be moved to the cold tier. Let's assume that this is the cold tier, right? If your data stays here for around what? Let's say it's not working properly anyway. Okay. So yeah, if you're using the hot tier, right, and your data stays here for 30 days, it's going to be moved to cold. Again, it's going to save money because cold is cheaper. But if that same data stays here for 180 days, it will be moved to archive. Okay, then you would be paying the prices for archive, which is super cheap. Okay. Other than this, right, if one day you decide that, hey man, I have some data that's in my archive, what should I do? If I have my data that's in the archive, and what should I do? Then when you want to access the archives, it's going to take you 6 hours for your data to actually move to the hot tier from where you can access it. Nobody can directly access the archive tier. That's what I'm saying. It takes 6 hours
Okay.
for the data to move from archive to cold to hot tier, to be honest. So you cannot directly access archive tier at all. I hope this clears it up.
Yeah, it does. Thank you very much.
Problem. Any more questions on this, on storage? I can see that most of the questions are regarding blobs. I would appreciate if some of the questions are regarding Azure file share as well, because again, this is kind of important too. So if you have any questions regarding either of these, shoot away. Okay, so that means that we can move forward. So, okay, eventually if you get any questions or you get confused with any of these things, just let me know. Okay, I don't want anybody to focus too much on these slides from other than file share and blob. Don't focus on any other storage that is shown in this slide. Okay, we need to focus on two things. There are two major storage services that we are talking about here: containers and files. Containers, blobs. Okay, so files use SMB and REST access. SMB stands for server message block. It's just a protocol that file servers use, right? Customer is using if your customer is using a file server, they're probably using an SMB protocol. That means we can support that file server. We can actually uh, do a whole lift and shift kind of a thing. What does lift and shift means? What does lift and shift mean? Is that we can take the file server and bring that file server over to the cloud directly, right? And you can access it from anywhere. And it's a secure access. Microsoft makes sure that access is secure and all the data is actually, in this case, we use two terms for secure access. Have you heard of encryption? Everybody must have heard of encryption.
Yes.
Yeah.
What is encryption? Let's get into that for a second. Anyone?
It's written in a code that needs some expert to decipher it. It's not just available to anyone.
That's cool. So basically, it's like a code word. If you have code words, that's what it is. It's encryption. I'm making my data or a plain data into a crypt. It's a cryptic writing now. So the idea here is for encryption is that let's say the data is ABC and I'm calling it 123, right? So for every encryption there is something called as a key. right? For every encryption, if some data is encrypted, in order to decrypt that data, a person would need a key, right? Usually the key rests with the person who's encrypting the data. Then the key has to be sent to the sender so that sender can decrypt the information, and so on and so forth, right? In Azure storages, encryption is done on all the data that's on Microsoft Azure storages, right? It's encryption at rest. For all the storages that we have, the data that is stored there while it's at rest, it's not moving anywhere, we encrypt that data. That's number one, right? And then we have encryption at transit. When you're accessing the data, when the data is moving from point A to point B, Microsoft makes sure that the data is encrypted even then, so that nobody can do a man in the middle kind of an attack. It's a security attack, uh, in order to take what data is there, right? So data is encrypted both at rest and at transit, right? So that's true for our file server, that's true for our Azure file share, that's true for our containers, that's true for our disks, that's true for every storage that we have on Microsoft Azure, right? There are some blobs for unstructured data or text or binary data. You can store that on the blob. We have other types of blob as well, blog, page, and append. We don't require this information. We just need to know that there are three tiers: hot, cool, and archive. If you want to learn more about page, append, and blob, right, you can contact me after this training session, or you can just look it up into the AZ fundamental link that I shared with you guys, right? We also have some tables here, some queues here. We're not going to get into all of that right now, but let's keep it very simple, right? So for all the Azure storages, the encryption at rest is there. It's durable. Somebody said the resilience is 99.6 nines after that. So 8 nines of resilience in this, right? Replication is strongly consistent. Replication means that, okay, this is very important. If you keep a piece of data, or if you upload a piece of data to Microsoft Azure, what's going to happen is that we are going to make sure that there are 3 copies of that data always. You create a blob, you upload a few files there. It's going to be, my bad, let me rewind a little. Okay, you create a blob storage, you upload a few files there. We are going to make 3 copies of it. We are going to keep 3 copies, a few in the same data center, a few in different data centers. So Microsoft Azure at all times has at least 3 copies of your data and has at most 18 copies of your data, depending upon what kind of redundancy the customer has chosen. If they want their data to be super important data, I want it to be super redundant, available all across the globe. So I will make multiple copies all across the data centers, all across the globe in different regions. That's what I would do. But for people who are just, okay, let's store some data, then okay, do this regular replication where we have 3 copies, right? That actually helps us with the fault tolerance part of the things, as well, as you can see here, and automatic load balancing. Customers don't have to worry about, okay, where is my storage being accessed from? What does the customer have to do? We are going to help them with the load balancing part in the backend, so nobody has to worry about anything in this case. Everything is managed by Microsoft. Okay. Moving on, we have some network services, right? Well, first of all, I would suggest you guys one thing. There is no need for you to specifically pitch network services. Okay, one question. Is anybody here handling enterprise accounts, or are we all working with SMB accounts for now? Anybody handling enterprise accounts?
No, Yardad, I think we are also SMB.
Okay, everyone's for SMB. Okay, so we have something called as okay, I'll just go over some of these network services. Not all of these are relevant for us. Okay, so this is VPN gateway. You can see VPN. VPN stands for Virtual Private Network. It's a secure connection. That's all it is. It's a fancy name for a secure connection and encrypted connection, right? So basically what that is, if you have a server on Azure and you want to connect it to a server on the on-prem, some people are concerned about security on the cloud. What we do in Microsoft Azure is we can encrypt the data from that server on-prem to the server that's in the cloud. We call it the VPN gateway. We can set up a VPN connection from the Azure cloud machine to an on-prem machine. That's one thing. Okay. Then we have something called as content delivery network. Has anybody heard of this CDN or content delivery network?
Yep.
Yes.
Yeah, I have.
Oh, please go on. Somebody please explain.
It's
Yeah,
content
so-
delivered from. Oh, you carry on. You carry on.
Oh, no, thanks, Seb. Yeah, a CDN is when items, typically I know it in the web context, so things like video, any kind of content, so video, pictures, animations, that kind of thing, is stored on a network which is closer to the client, so it like speeds up load times for them. So
Beautiful.
if the website is based in Texas, but somebody's accessing it from the UK, that content will be on a server closer to the person who's actually browsing as opposed to where you're hosting.
Awesome. So any examples of this?
Netflix.
Of course, Netflix, right? So all of us, if we are at different locations, right? The first question would be, where is the Netflix server? Most people would say probably somewhere in the US. That's where the head office is, right? That's where the headquarters are, right? So if everyone in the world was accessing a server that's in the US, that is going to be so awfully slow, right? So for Netflix and for YouTube even, right? They have certain servers located in the regions where there is a big customer base, where there's a big consumer base, probably a server in the UK, probably a server in India, a server in Brazil, a server in Korea or China, something like that, if they have Netflix. So the idea is content delivery network is for organizations that have their customer base all across the globe, and they want to make sure that the customers are accessing services from closer to their place so that latency is as low as possible. That's what a CDN is. So mostly since we are all handling SMB clients here, a CDN is very less likely to actually come up in a conversation, right? Since they're all SMBs and that's a smaller company. But if you see an opportunity like that, just know that we have it. We provide CDNs as well. Okay. Then we come to databases. What is a database? Can anybody explain what's a database? Well, the way you could explain it to a 5-year-old. I don't want to hear about the instances and stuff like that, because that would confuse all of us. So anyone, what's a database? Nobody?
It's a base where you put all your data. Simple enough.
I'm really loving your answers. So,
I can give it a try.
who said yesterday that servers are black in color?
That would be me. I said it could be black because I was referring to the machine.
Okay. So, okay, fair enough. So, so database is a place where we are keeping data. Fair enough. But how is it different from storage then? I think it's storage. It's just a place where you keep all the data. Yes, anyone. What's a database?
Yatharth, I can give a quick shot.
Sure. Please.
It's basically stacking up all data in a more index and a more, what do you call, in a more disciplined manner, so that retrieval of data is easier. I'm just saying in a very layman.
Of course, we need this. So, can you guys still not see my screen? I can see Esther's message here. Okay, she found it. Anyway, so let's talk about databases for a second. First of all, if I write some random data, it would be kind of difficult for everyone. So everyone has seen those classroom attendance rolls. You have an attendance register, everyone's name is on it. There's we mark present every day. So it's in form of a table, right? What does database do and how is it different from any other kind of storage? The idea is that database is you can say it's in a more structured form. Databases are structured. So why do you need a structured storage? If you have a lot of data and you want to find out patterns out of that data, or if you want to take some insights out of that data, or even you just want to traverse that data easily, you want to you want to see that how many people attended the office on 26th of March. Well, you have the database, you can check it in the database. But if it was some storage where there was randomly kept information, it would have been kind of difficult to find that out, right? So databases actually help us a lot with finding patterns in the data, right? And with actually searching the data really fast, right? So that's what databases are used for. One simple example of a database that we almost use every day, or most of the people use but don't realize, is Microsoft Excel. It's technically a database. When you have an Excel workbook or Excel sheet or whatever that is called, right? You have a lot of information on that, maybe 5-10 megabytes of information, and it's a pretty big workbook in that case. In case of Excel, you can see you have the data there in a very structured manner, right? So why do we even need a database if we have Excel? Because again, if the database is all structured and it's all in form of tables and tables are related to one another so that I can find information out of that Excel sheet, why not use Excel everywhere? Why use other databases? Anyone? Why use other databases?
To get the better output in less time.
Get the better. Okay. Hold on for a second. Is there still disturbance and noise on the line or not? Just let me know if there is.
It's fine now for me.
Oh, okay. So, yeah. So the idea is that when you're working with Microsoft Excel, and most of us would have seen it, if the Excel file is like what 25, 30 megabytes, only 25, 30 megabytes, the Excel becomes really slow. It's a lot of data, and that software is not designed to handle so much information. So there should be, when I'm talking about gigabytes and terabytes of information stored on the databases, it's going to be a difficult task for anybody or any random software to actually manage that information. So databases are actually first the storages and the software to manage those storages so that you can save the data. So that you can save the data on a storage in a well structured manner, and you can search through it with ease. You can find patterns from it. You can probably visualize the data as well. Data visualization is making bar graphs, pie charts, and stuff like that. Everything that makes it kind of easier for us to understand what data is, make it more insightful. We can all do it only when our data is structured, right? Probably go back to class 8, standard 8, when we were doing those chapters of graph theory and when we were making graphs in the math class, right? What was happening is that before you create a graph, the first thing you need to do is to create a table. Create a table. There would be a row, a column, a few information, a few points of information. Then we will plot those points on a graph, and then we will create a graph. There is no data visualization before structuring of data. If the data is unstructured, I'm sorry, we can't have any kind of data visualization. So your tools like, I'm pretty sure by now everybody has heard of Power BI. It's a business intelligence tool. In a nutshell, it's just a data visualization tool too. You cannot use Power BI if you do not have a structured database. Power BI is not for you. Forget it. If you don't have a database, we can't give you Power BI. Or if you want to use Power BI, it has an inbuilt database, but you require a database. What my point is behind this whole 8-minute rant of databases is that databases are necessary, and they have a lot of information in bulk, and there are specific tools that can cater to your database needs, right? One of those tools is SQL. SQL stands for, well, most people just call it SQL, but SQL stands for Structured Query Language. It's just a language, structured query language. It's just a language that we use to query the database or find the database, find the information in the databases, right? It's just going to do that, right? It's just a language. So when you see Microsoft SQL database, what that means is that, okay, it's a database created by Microsoft, and it uses SQL as a language to traverse through that data. That's all it means. Okay. By the way, uh, when you are talking about on-premises, databases are not just on cloud. Most of the people still have their databases on the on-prem environment, right? What they do is that they get a server. On that server, they install an operating system, right? After installing the operating system, they install a software called as Microsoft SQL, maybe 2010, 2014, 2017, right? They can go for any version. That's a database software, and then they create a database, right? You have to purchase a license, a separate license for Microsoft SQL 2017, 2014, and all these products, 2011. And all these products, you have to purchase a separate license, right? But if you want to move to the cloud, is there any way to do that? Because SQL is just an application, Microsoft SQL is just an application. Can you host it on a virtual machine? Is my question. Can you host Microsoft SQL, the application, on a virtual machine?
Yes.
Yes. Okay. So the answer is yes here. So how? First, step 1, get a virtual machine. Step 2, install SQL on the said virtual machine. Step 3, well, get a license for, excuse me. Step 3, get a license for SQL, right? Or probably pay Microsoft per month for that SQL installation too. We have that option as well, right? So this is the whole IaaS kind of a route, right? Get a virtual machine, install SQL on it, go ahead, you're the boss of that database, and make as many databases as you want to, right? It's totally up to you, right? So that's one thing that you can do, but that is kind of difficult to do, right? Because it's kind of difficult to manage and all that stuff. You have the control, so many people like the idea of having control over their databases, right? But it's super expensive. It's pretty expensive because you are getting the whole virtual machine, then you're getting the whole SQL software just for yourself. Nobody can share it, right? So it's what should I say? It's not the most cost-effective solution, right? But we want some cost-effective solutions too. So Microsoft says that, dude, why do you have to get your own virtual machine, get your own SQL, and deploy everything when you can have an Azure SQL database? What is an Azure SQL database? This is platform as a service. Microsoft just gives you the database, right? You just as a person who is running their application and stuff like that, most likely I would just require the database. I don't know how to manage the whole thing, but for my application, I just require a database. So that's why I'm getting a database. So I go to Microsoft and I say that what's the easiest way? And they say go with Azure SQL database. The virtual machine on which that is deployed is Microsoft's virtual machine. They are managing it. They have installed SQL. They have done everything that I said in the previous step. But for me, they just give me a small part of that database, right? They just give me a small part of that database. They give me what we call as a database instance. I'm not the owner of the whole database server, but I'm the owner of my database, right? That whole database server might have like 20 different databases given to 20 different users, but for me, I am the owner of that particular database of mine that Microsoft has given me. This is platform as a service. This is called Azure SQL database, right? So this does is it brings the cost down considerably. It's very cheap. Again, you have slightly less control, but some people just don't want to control it. Honestly, if I'm hosting my application and I'm hosting my application on Microsoft Azure, I'm not using my own database, right? I've taken the database from Microsoft. They are managing it and they are responsible for keeping it up, right? So why would I manage my own database and be the DBA as well? I don't have the time. So I'll probably go with platform as a service solution. Some people also refer to it as DaaS or database as a service, right? Any questions so far? Any questions in the differences between this virtual machine database and the Azure SQL database?
From a management point of view, I just wanted to understand that if I'm using SQL as a service, do I get like how do I access the logs, the Windows logs or the system logs in case I need to troubleshoot something? Is there an option for that as well?
That's the beauty of it. You don't have to troubleshoot anything, right? First of all,
Even if it is an application related error.
Those logs will be accessible to you. Those logs will be accessible to you because they are giving you the whole database instance. Instance is still yours, right? But if you want to troubleshoot the database server, we don't have access to that. We just have the access to the instance. So application failure, of course, we can troubleshoot it and logs and all that stuff is available. Yes. Anybody else? Any more questions on this?
The difference between VM database and Azure SQL database, can you please explain?
Difference between Azure database and your on-premises database is nothing.
On-premise, I mean in the virtual machine. Suppose if I buy a virtual machine, so must be I'm getting some storage, right? I'll be buying the storage also. So is there any difference between the storage which I get in VM? If suppose if I'm buying a
the differences between the amount of control you have. Differences between the amount of control you have. In the VM, you can control the storage, you can control the operating system, then you install the SQL. It's up to you how many instances you create. It's totally up to you, right? In case of Azure SQL, you are just given one SQL instance and you use that for your application. That's about it. You don't have to worry about, first of all, I can put it in two ways. You don't have to, you can't control your storage, you can't control your operating system, you can't control your SQL server, you can just control your SQL instance. Or I can put it this way, that you don't have to worry about your storage, you don't have to worry about your instances and all that stuff. You just have to worry about the database instance that they have given you. So the difference is exactly what the difference is between IaaS and PaaS. That's the whole difference. Cost-wise as well, Azure SQL database would be cheaper than having a database on a virtual machine, right? But
being as an individual customer, I can buy a single SQL database, right? Only SQL database.
Only SQL database instance, nothing else. You'll just pay for the SQL database instance, nothing else. So it's just like the application service that we were talking about. You don't have to pay for the whole VM. You just have to pay for hosting your application. That's it. That's the whole difference between IaaS and PaaS.
Okay, thanks.
Okay. Any more questions? So it's totally up to you in this case is how you want to approach these things with the customer. If the customer seems like that they want to control everything and they have a team that knows, they have a database administrator who would want to create their own database and have their own schema and stuff like that, just tell them go ahead with SQL on Azure VM. That would totally work. And by the way, it's one of the best selling things that we have, right? Because people kind of look for control in their databases, but certain people will do okay with slightly less amount of control. That, let's say I have an application and that application just requires a database. Why do I need to be a DBA? Why do I need to be a database administrator when I can just use a database and Microsoft can act as my DBA? Well, that's totally up to your customer. That's totally up to your judgment when you're talking to the customer as to what will be more suitable for them and what would be more suitable pitch for them going ahead, right? You can pitch both of these things, but well, you don't have to if you understand what they are actually looking for, right? So any more questions out of this? Then we can discuss other database types. Okay, let's go ahead. So first of all, we then have something called as Azure Cosmos DB. So most of the customers that we have, they are SMP customers, right? They are going to be really happy, and I'm telling you, they are going to be super happy, and your revenue is going to be pretty nice if you are well versed. Now, this is up to you. You have to be well versed with the SQL database technicalities and stuff like that, because again, you can talk to anyone in that case, right? And you can identify opportunities earlier if you know more about your products, right? So for certain people, they have their customer base all across the globe, like we were talking about CDN earlier, right? What if there was a customer that had like that were covering a customer base of 50 to 60 countries, let's say, all across the globe, and they have clients all over that region, right? 3,000 clients. So there's more than 100,000 clients all across the globe in different places. And all of them wanted to access a particular database, or all of their applications wanted to access a particular database. Now the question comes in, where do you host that database? The answer is everywhere, right? Cosmos DB, Azure Cosmos DB, is a globally distributed database. No matter where you are hosting it, the services and the latencies are going to be low all across the globe for the customers, right? It's slightly more expensive, right? It's very scalable, but it's not meant for people who are looking to pay less. It's meant for the people who are looking for top-notch services all across the globe, because it's globally distributed and you can scale it up anytime. It will automatically scale up, right? So that's why it's called the Cosmos DB. It's meant for like huge databases, right? And it's basically, it's ever present, it's everywhere, right? So that's why it's called the Cosmos DB, right? So you can actually use that as well, right? Now you will get one question, you will get one kind of an objection from the customer, is that okay, I understand that you want to sell me on this idea of moving my databases to the cloud. How are you going to do that? What the migration is going to look like? Is it even possible with my database or not? Whatever their concern is, it is always possible. No matter which database they're using, no matter what kind of database and how old the database is, that database is from, it's from Oracle or somebody else, it is going to work. The answer is going to be yes. There is a tool. It used to be a tool. Now it is a service called as database migration, Azure database migration. You have any database, the customer has any database, we are going to migrate it to Azure, well, fairly seamlessly, right? Again, it will depend upon the type of the data and type of the database, how long would the migration take and how complicated would the migration be. But overall, we have a service that is going to help to migrate and help to perform all the lift and shift kind of a thing. from on-prem to Microsoft Azure. Yes.
If the data is like mainframe, like DOS format, is it still possible to migrate it?
Well, actually, yes. Which vendor is it from?
No, just curious. For like old databases in banks that are still on mainframe, possible, right? To
Of course it is. I told you one thing. If they are hosting the servers, if they're hosting the server on-prem, we can host the server on the cloud. What I would do, I don't know what kind of data would that specifically be, but my safest bet would be, okay, get that data onto a VM. Of course, move that whole thing to an Azure VM. Whatever data they are using, whatever server they are using, whatever software they are using, everything exactly the same on an Azure VM. They are now on cloud. Now we can think about upgrading and stuff like that. It's not that you have to upgrade and then move to the cloud. You can move to the cloud and then upgrade as well. Right. So yes, for old banks and for people who are using these old servers, age-old servers, can they move? Of course they can move. We can create some sort of an environment for them in which their services would totally run. Okay. So by the way, for anyone, if you're going to get this objection that I have legacy applications and my applications won't run, I have a legacy database, my database won't run on cloud, well, just tell them it's going to run. We run that for so many people all across the globe, and it's, well, fairly seamless, right? Now, there's one more question that comes in from the customer's end, is that how long would it take for my migration to take place? Which is actually a very, I don't want to say stupid, but it's actually a pretty, it depends, to be honest, right? It depends on how much data there is, right? How much time will it take for me to take my backup? Well, how much data do you have? Is it 1 GB? Is it 1 TB? Is it 1 PB? It depends how much data you have. In the same way, how much time will it take for me to migrate to Azure? I don't know. It depends. So we will not commit to anything, right? It depends upon the amount of data that they're moving to the cloud. It depends on the amount of internet speed that they have, right? So things like that. So the timeline would be, we are going to provide you with it should take you like a very short amount of time, right? But we can't promise anything. And is my database going to work on the cloud? Of course it is, right? So these are some things that we can say to assure the customer that, okay, everything is fine. Not all is lost when you move into the cloud, right? So have you guys heard of DevOps? So now we know we have a DevOps engineer here. So please identify yourself and tell us what DevOps is.
Well, DevOps is a very wide term, to be honest. It includes everything basically related to the cloud, be it managing the code, be it managing the service, or be it managing the applications. So it has various. It is more operations related, and it is more management related, to be honest. So and when all goes down, you're the one who's to answer, like, why is everything not working?
Why everything is not working?
Yeah, because then you have to answer your organization and the client that why are we breaching the SLAs when we've promised a 99.99% uptime.
But that can also happen in a non-DevOps approach too, to be honest.
Yeah, that is right though.
But anyway, so yeah, Deepak, you were saying something?
Yeah, as per my understanding, this DevOps is especially for the software development team that they start their project, they develop, and then they go ahead and they run that particular program to detect whether there are bugs or not. Because earlier there were three different teams that used to work. There was a team who used to decode, work on the codes, then they used to pass to check whether there are bugs or not. And this DevOps, it's under one roof where a person, a developer, he decodes it and uploads it and it runs the bugs. And if everything is okay, then move forward.
Deepak, in all fairness, there are still different teams for all of these things. The teams have not changed, right? The
Yeah.
testing team is still there. The operations team is still different.
Mhm.
Development team is still different. Okay, for everyone, let's make this more inclusive here, right? So, what is DevOps? DevOps is not a software, right? DevOps is not a product. DevOps is just an approach. Deepak, can you please mute? There's background noise
Oh,
coming
I'm
from your
so
end.
sorry. I'm so sorry.
Okay. So, DevOps is basically an approach. It's not a software, it's not a product, it's nothing like that. It's just an approach. It's like bringing the development team and bringing the operations team closer to each other. Right. Let me explain how that works. Right. When I'm saying DevOps, earlier, let's go back a few years. If you were developing a software, what would it look like, right? First of all, I'll develop the software. There's a developers team, right? Developers development team would work for 6 months on that software, right? That software would be developed. Okay. Now it will go for quality and testing and all that stuff, right? It will stay there for 2-3 months. Probably everything would be tested and quality would be checked and stuff like that. If everything is fine, that's great, but mostly it's not fine in the first go. So it will go back to the development team. And while the quality team is testing the code, and while the development team is testing the product, a quality team is testing the product, my bad, is testing the product, the development team is uh, not really doing anything, right? Honestly. But when the quality team is done with that and they send it back to the development team, now the development team has a deadline that they have to fix that bug, they have to make everything fine, and they make changes to the code again, and they send it to the quality team again. And the meanwhile, quality team is testing again. So for all the teams, it's just like either it's way too much work or it's no work at all, basically, right? With the old software development approach, this is a software development cycle. After this, it will go to the testers. After this, it will go to alpha testing. Then there will be beta testing. But the idea being here is that they develop the whole application first and then test it, okay? Which is kind of a slow process, right? At the end of the day, you are still going to get the application probably after a year or probably after 2 years, let's say, realistically. You can see anytime you have, let me take an example. Uh, some of us play video games, let's say. How long does it take for a sequel to a video game to come out? Usually, how long does it take?
Over a year.
A year?
A year, 2 years. Uh, if you are Max Payne fans, then probably 8 years, 9 years. So it takes a long, long time, right? So the idea is that everything is being developed from the scratch, then it's being checked, then it's being scrapped, then being developed, then being checked, then going to testing. It's a huge process, right? Wouldn't it be so awesome that if I developed a feature, we test we send it directly to the quality people, they test it, right, while the development team is already working on it. If it's not okay, then it will come back, the development team will fix it, and it will be released to the public. That small feature would be released in the public, right? DevOps approaches, let me give you an example. We are all most of us use WhatsApp, right? uh, which version of WhatsApp are you using exactly? That's a simple question. Which version of WhatsApp is it? Any guesses? Don't just go to settings and check. Just any guess.
I believe it's a beta version.
Using the beta version. I was asking the version number, to be honest.
Oh,
So okay. Let me clarify this. Okay. So from the time that we first used WhatsApp, probably some people used it like 5 years ago. I used it 4 years ago, five years ago too, right? From then to now, has WhatsApp changed? Of course, it has changed. It has changed a lot. But was there a time that you had to install a totally fresh WhatsApp and everything changed overnight? It never happened. Nothing changed overnight, right? There were small features that were added. There were some features that were redacted. So They were adding some features, they were removing some older features, they were introducing something new, making changes to something. But there are a few updates that happen every couple of weeks, every couple of months. You have to do that small update, and there is a small change in the WhatsApp. But overall, WhatsApp looks pretty much the same, right? This is more or less a DevOps based approach. The application is still there. I'm just introducing a new feature as a developer, right? Quality team likes the feature. They release that feature to an audience, right? They release that feature to maybe an internal team, right? They test it. If they like it, they are introducing the feature in the market or in the application. So all of this process, rather than taking 2 years and a whole application, now I'm just introducing some new features, right? But I'm doing it every couple of weeks, every couple of weeks, every couple of months. So what it does for me is two things. First of all, I don't have to make a lot of major releases. I don't have to major release a WhatsApp again. That ladies and gentlemen, stop using WhatsApp. It's WhatsApp 3.0 coming out. It's not like that. It doesn't change a lot. Okay. And another thing is that the changes do not take a lot of time to come out. It does not take a lot of time for changes to be rolled out into the market, right? In this way, I can sense the market slightly better, right? Okay, Instagram is using stories. I'll use stories in WhatsApp too. Okay, Snapchat was using stories. Instagram started using it. WhatsApp started using it. Now Facebook is using it too. They are just rolling out the features just to check it whether they are working. If people like it, we are going to keep it. If they don't like it, we are going to throw it all out, right? This is more or less the DevOps approach. I am spending, well, I'm constantly working on something. I'm being consistent about it, and I'm making smaller changes. So overall, my product is going to change, but it's not like the whole life cycle of 2 years or something like that, right? Uh, Most of us know that Windows 10 is not going to be up. Okay, there's not going to be another Windows. Has everybody heard of that? Yes? No? There's not going to be another Windows from Microsoft. Is that true or is that false?
I believe it is also because there might be certain changes that they might go ahead and add to it to make it more convenient for users of XP and 7.
But it would still be Windows 10, right?
Yeah, Windows 10.1 can be 10.1 also, but still it will be
You
10.
can name it. You can name it whatever you want. But let's
Yeah,
compare it with when Windows 10 was released. From then, if you compare Windows 10 now, well, it's a totally different operating system, right? But they're still making changes. They are going with what it's kind of like the Apple model. It's going to upgrade, upgrade, upgrade. Sorry, my bad. It's going to update and update and update, but you would not require an upgrade because everyone, even including Microsoft, we have moved towards a more DevOps approach of doing things, right? We are developing, we are testing out a new feature. We don't like it, we take it back, right? So after a while, there will be no specific need for a new operating system because the one that we are using right now is up to date as it is, right? So Dipanshu, is that okay? Is that the DevOps approach? Do you want to add something to it?
I couldn't have said it any better even if I tried.
Okay, thanks. So DevOps in this case, what are we selling? Like I said, that there is no product, right? But honestly, there is a product, right? In Microsoft Azure, we have a product. If you want now, the thing is, if you want to work in a DevOps approach, if you want to use a DevOps approach, you can get a product from us called as Azure DevOps Services. Now, what we are going to do is that all your developers, all your testers, all your operations people, everyone under the same roof is going to use the same platform. That platform is going to be Azure DevOps Services, right? Developers can create the applications, testers can test the applications, or you can create these, what do they call these dashboards and repositories can be created, right? Testing can be done right then and right there, everything within the same portal. You don't require different tools for testing. You don't require different tools for development. We are including everything in one service. We call this Azure DevOps Services. So anytime you're talking to a customer that's a developer or it's a firm that develops applications, Azure DevOps Services is the way to go. You can use these fancy terms even if you don't even if you don't totally understand these terms like Git repositories, Kanban boards, load testing, and all that stuff. You can still use these terms. They would get it, right? So the idea is that once you explain to them that we have a platform that helps that can help a company with the DevOps approach, and you can include it all in. Yeah, that's actually the way to go. So DevOps is one of the products that if you make a sale on this, you're going to be pretty happy with the revenue that you see, right? So that's one thing. And by the way, if anybody gets stuck with DevOps on the call, just let me know. I'll take the call myself. Okay, if you require any assistance on this, right? And Azure DevOps has become a really popular tool. So if you're talking to a developer, development head, or a company that develops the application, chances are 99 out of 100 they have heard of it. Okay, so yeah, of course, you can have a conversation regarding DevOps. Any questions so far on Azure DevOps? No questions? Okay, so let's do this one thing. We'll come back to all of this. Let's take 20 and then we will make a 1 hour stretch. How does that sound?
Yeah, sounds really good. Thanks for this.
No problem. So
Thank you.
be back in 20 then. See you guys.